Hi guys, welcome to the first demonstration of this system. Just a few quick points before we start. This is purely a functional demo. It just shows how quickly and easily you can create an app and shows how your devices continue to work as expected offline, peer and mesh connected. It also shows how you can update the app and push out new changes to your devices while they're still running. I have only just got this very basic early prototype running, and unfortunately I'm not at the point where I can show a lot of GUI features or decorations. The production system should allow you to make an app that looks like other apps you've seen. On the screen you can see three devices. This is device B would use a Ben, device C would use a Carl, and device D would use a Dan. And you can see that there's an application running in the three devices and it looks like it's the same application. That's because the application's been synced to all the devices. If I make a change in, say, on Ben's device, you'll see that that message has actually been sent out to all the other devices. Now this is the simple social network messaging app example. This is actually the result, so the rest of the video will show you how to build this app, and this is the app you end up with, and this is a timer that showed that we did it in 5 minutes and 33 seconds. And so you'll see this being built. So on the left here is the wall. That's Dan's wall, Carl's wall, Ben's wall, Adam's wall. And you just write messages. And it doesn't matter where you write it. It's all being synced around. So up here, this just points out that this is a platform agnostic solution. So the app you create is platform agnostic and it runs on a runtime. And at the moment, the runtime here is a Java runtime running on a Windows device, and that's where we're doing the video recording from. So I just say this is Android because this could be an Android device and your app would be running there. This could be HTML5 in the browser, so you'd see the same app running in the browser, and you could be running on an iPhone, iPad, and it'd be the same app again. Now to get these three devices here, I've had to run the runtime 3 times, so it'd be like running Android 3 times on a phone to get the 3 instances up and running. So normally you'd only run 1 instance on a device, but it lets me do the video capture of 3 virtual devices for the demo purposes. On the left here is the connections control. Now it actually shows 4 devices. Adam is a Wi-Fi, so it's a local Wi-Fi connected laptop which is running 1 instance. So that's device A with user Adam, and that's where all the editing's being done. And these other devices are here to show you the result of actually creating the new program. And I can change the connections between the devices as I like. At the moment the devices aren't connected to each other. If I connect Adam and Ben, it says Ben's connected to Adam, and Ben and Dan, so it says Dan's connected to Ben, Ben's also connected to Dan. So you can run any sort of connection scenario you want to do, and you'll see those during the course of the demo. Okay, now it's time to create the application. We see that device A is connected to device B and none of the other devices are connected together. So we'll be able to see as I create the application on A, we'll see it synced out straight away to device B, and you'll see what's happening as I go along. I'll start a stopwatch here just so we see how long this takes. So first we need to create the user list so we can select the wall we want to post to. So on device A, I need to create a wall. And then we just display that. So there we have a list of something. This is user information. On that, we'll select that we just want to show the user name. There. So there, we've already pre-configured for these 4 users on these devices, and that's our select list. So that will select the wall for Dan, and we'll be able to post to that. Now the list of users could be, you know, your company employees or family members. Okay, now it's time to create a message. I'll actually select Ben on all these, so we'll keep in sync when we sync everything up together. And to create a message, I'll actually have to create what a message is, and in our case the message will be a text string, which is the actual message, and we'll also keep track of the user who created the message so we can see who it was from. I'm just adding that at the moment. Okay, so I've added the data into the system, and now we just need to be able to create a message. So here you see that something's appeared, and this is where the new message is going to be created. And basically for the message we just want to enter the text. And so there's a text input where you type the message, and the user that created the message will be the login on this system. Okay, so that's all created. So I can now type in a message. What am I doing right now? I'm doing a demo now. Now I've actually added that, it's created a message, we just can't see it yet. So finally, all we need to do is show the messages. Now understand that what we've done at the moment, we've actually created a new data structure for the message. We've actually created new data here, which I just entered. We've added some new functionality, and we've updated the user interface, and we've kept them in sync. So to display the message, we want to display a list of them. So we'll add that functionality, and now that gives us a list of something. We then just need to decide what parts of the message we want to actually show, and in our case it'll be the text string which is there. So that's the message I wrote, and we get the user information and display that at the end. And there we go. So it says I'm doing the message, doing the demo now, and that's the user that created the message, which is on this device, which is Ben. And one more thing I'll add to this is an indication of how old the message is. So I'll get the create time of the message. Add that in, and that's when the message was created, but we'll show that as an age so that it's a bit easier to get an idea how old the message is. And we'll just do some reorganization of the display, and there we have it. So I can now type something in on the device A, and you should see the message appear, and that's from Adam, and so all that's now working. Now I've been editing this on what you see is what you get edited. Basically what you see here is what I'm seeing as I developed the program. We did a little bit of trial and error to get this working and relayed out a bit. Now we'll just sync everything up. And there we go. We've seen the information being transferred across to the other devices. We've also seen the layout, the data instructions, everything transferred across. So I can now type a message on Dan. I'll post this to Ben's wall, and everyone sees it. So now this is all just working because all the devices are connected. So that's working. It's been synced out. That was 5.5 minutes. Now it's time to look at some connection scenarios. So what I'll start off doing is we'll go to Carl's wall, and we'll start doing messages on that. And I'll start by taking everyone offline. So now everyone's typing their own messages. They can't synchronize to anything else, but it'll still work on the device. So on device A, I'll just type the letter A. On device B, type B. C gets a C, and D gets a D. And we'll do another round, and E on device A. F, G, and H. Oops, H. Okay, so as you can see, everyone is working offline. They've got the data they need, and the data they've added makes sense for the situation they're in. Now I'll bring A and B together, maybe Bluetooth connected, or they're on the local Wi-Fi or something. And there we see A, B, E, F. So Adam and Ben have synced their data and the times look about right. And I'll bring in Carl, I guess. So sync his device A, B, C, F, G. So again, the data is synced in the order it was created, and everything exists as it would have if the devices were connected at the time the data was created. And I'm just bringing Dan now, and again it's all just magically worked. Everyone's connected together and all the data synced, and I can just type in a hello message from Dan and it'll just pop around and everyone sees the same message. So the system's up and going, even though we're not connected to the internet at all and we're not connected to a server. This is the actual connection between the devices. So for Adam to get a message to Dan, it has to go through Ben and Carl's devices. We'll just do a bit more of a scenario here, just to see if we can actually see how long it takes for the message to go when it's being forwarded. You should notice a slight delay. If I send a message from Ben to Dan, this is Ben and he says hi, and if you watch Dan here, it'll be a bit of a delay as it runs around the system, but it can still make it. And if we just connect them directly together and kill all this, you should see it happens a bit faster. Of course, if there's no connection, as we've seen before, then nothing happens. Typically at a home Wi-Fi network, everything would connect to everything else like that and make a decent sized mesh, and you get redundant paths for the messages to travel. Okay, now we're going to take all this off again and we're going to update the application. So we're going to send Carl and Dan out into the field, and they can be Wi-Fi connected together but not on the internet, and Adam and Ben are going to be connected together, and I'm just going to do some updates and I'll show how you can update your system and push out the updates without causing problems for anybody. So what we'll start with is something pretty simple. We showed on the select list here just the username. So now why don't we show the user's age? So I select the user and he's got his birth date. We'll just add that in, and there it is. That's when he was born, and again we can show that as an age, and there you go. So that's just rolled out and the screen layout's changed to adjust for the different size of the information, as you would expect. And another interesting thing we could do, because that was just showing new information, but we could also change the data structure again and add some more data to show something else we can configure ourselves. And what I'd like to do is set an importance flag on the messages to say which message I thought was important and sync that out to other users. So I'll have to change the message structure here and add in some sort of importance flag. And now we can show that, and I'll just put it at the end after the user. Now that just said it's not important. That's not a good way to change information, so we can do this as a toggle button, and there we have it. So if you watch that, and I'll toggle it here on Adam, you can see the top message is being toggled as important or not important. So that's it. We've now made changes, and we've seen the changes live sync out to Ben from Adam, and now we're just going to introduce that. So out in the field, we'll have, Carl and Dan will be messaging each other. Hi Dan. So they've been running around messaging. Those messages haven't been synced across to Adam or Ben. And Adam and Ben can send some messages as well. Hi Ben. Now, we'll go back to some older data, something a bit more historic in Carl, and on this we'll actually change the importance flags on the first 4 of those. Okay, now we go back to Dan, and say Ben and Dan come in Bluetooth Wi-Fi range and start sharing data. The new application gets synced out, again the new data structures, the new data, the new GUI layout, and if we see here, we had the true importance set on that message, and if we go to the other messages here, we flag the first 4, even though Carl and Dan didn't have that information. It's been all synced out and updated as it was set on Adam and Ben's devices. So again, what we are seeing is what would have happened if everything was connected at the time, but they weren't, and now that they've been synced together, this is exactly what you would expect to see. Let's understand what we've just done. Remember, this is a very early prototype and only shows some of the functionality this system is capable of. Even without all the GUI components, colors and borders, we were still able to show how to build a simple app. There was no internet connection used. I could have done this demo castaway on a deserted island with Tom Hanks. There was no server used. All devices worked it out between themselves. None of my data was ever stored on the internet. It was kept private on my devices. The app I created is platform agnostic. It will run on any device that has the runtime. Think of the app as being analogous to an XLS spreadsheet file, and the runtime as analogous to the Excel application, only more powerful. I was able to run 2 devices together on version 1. At the same time, I was running 2 devices together on version 2. I didn't have to stop the world to update all devices to the latest version before I could use the app again. Devices share the new version of the app directly from device to device. There's no need to talk to a server to get it. Devices being upgraded from version 1 to version 2 continue to run and could still be used during the upgrade. Think of how this is different to what we do now. I connect my Android device to the Google Play Store internet server. It downloads the complete new Google app. The running Google app is killed and uninstalled. The new Google app is installed and started. Then I have to go back to where I was to continue working. This system has been designed to be easy to use with the what you see is what you get editing directly on the running app. Offline peer mesh and internet connection scenarios are provided by the underlying system. The user doesn't need to worry about it. Next year, school children will be able to create powerful collaborative apps directly on their tablets during their lunchtime. That's the level of simplicity this system is being aimed at. Thanks for watching the demo. Hope you enjoyed it. Bye.